Today, video tutorial we are going to discuss about immunoinformatics, and for this uh, uh, today we discuss on the three, uh, three tools, that is protparam, vaxijen, and NetCTL servers. And for this uh, tutorial, I have selected faster sequence with the PDB number 677, which is a part of non-structural protein of SARS-CoV. And before to start, I want to tell you about a little bit information about these three tools. Protparam is used for the physicochemical properties for the particular protein which we are selecting, and the vaxijen is used to check the antigenicity of the protein sequence, or maybe for the peptides which we uh, draw, which we just after using the NetCTL server. And NetCTL server is used to T cell epitope prediction. And now we're going to start. First of all, we selected 6LU7, and we checked the physicochemical properties of that particular sequence. As I already shown this sequence in the plain form. In instructions, we can use only the plain sequence without its ID. Now copy that sequence and paste the master sequence in this folder as you show paste here. But in upper we can give the ID, maybe input ID or PDB ID. Now we use the master sequence and simply click on the compute parameters. Within a second, the result will be shown on the screen. And first of all, here is the sequence that shows 300 or our sequence 306. And if we go to the information or the documentation available as per our experiment, first of all, number of amino acids, this protein has 306 amino acids. If we talk about molecular weight, and our protein have 33,796.4 molecular weight, and theoretical इंडेक्स जो है इसका वो 5.5 है. And one more most important information, amino acid composition is shown. Alanine has 17 residues and overall percentage of the protein sequence is 5.6. Yes, similarly, from top to bottom, these are last one, the protein shows only 0.0%. नेक्स्ट टोटल नंबर ऑफ नेगेटिवली चार्ज रेसिड्यूज जो हैं वो इसमें टोटल नंबर ऑफ पॉजिटिवली चार्ज रेसिड्यूज जो हैं वो 22 हैं. इसी तरह एटॉमिक कंपोजिशन, कार्बन सी जो है प्रोटीन 99 है, हाइड्रोजन 23 18, नाइट्रोजन 402, ऑक्सीजन 445 and so on. One important information which provide in detail, aliphatic index जो है वो 82.14 and the grand average of hydropathicity. In other words, we must talk about the gravity. This information shows about the hydrophilic and hydrophobic nature of that particular sequence of that particular protein. If the value is positive, then we consider it as hydrophobic. And now in this information, in this experiment, our value is negative, then this protein sequence is hydrophilic in nature. This all about protparam, and now we will go to the vaxijen. In the vaxijen, we can check the antigenicity of the protein sequence. Same as we've done before, copy that sequence and paste that file. And we are working on SARS-CoV-2 virus. Then we click here the virus, and the by default threshold will be 0.5, and other parameters will be as default. We select the species. Yeah, in other words, we can say target organism or threshold, and simply click on submit. As we click on submit, and the result will be shown on the screen. Overall prediction of the protective antigen 0.4149 probable non-antigen. If the value is 0.5 or more, then the result will be shown as antigen. Here is non-antigen. In other words, non-antigenicity is present in this particular potency. This is all about the vaccine. In here, same as we paste the FASTA sequence, and if we say paste here the peptide sequence, then this value will be shown that particular peptide is antigenic or non-antigenic. Now we move for our third software or the third server, NetCTL 1.2 server. NetCTL server, on the home page, here are some instructions which will help us how we perform or how we design peptides. First of all, enter the sequence window or give a file name. Same as before, we can paste a master sequence in the plain form, or we will provide the sequence number from the database, which will be PDB number, UniProt ID, etc. Second point, supertype 10 HLA supertypes are available. These are the you can say parameters. Optionals may in these are on the C-terminal cleavage. If we talk about these four main points, which will going to report in publications in the tabular form, and the result will also be shown on the screen. C-terminal is the end of an amino acid chain. Uh, where the amino acid ends, that's known as C-terminal cleavage, and the tap transport efficiency binds 18 to 16 peptide residues, while the binding of 8 to 12 residues are most efficient. If we design the peptides in the range, the our peptide will be in the range of 18 to 12 residues, then it will be more efficient in our later on cells. Threshold must be by default 0.75, and we can change. Now in the first experiment we will do it as on by default settings. And the next is the prediction score, or sort by the score. Prediction score will be range 0 to 1, and the higher score shows the higher possibility to predict to be the true in ACB. In other words, ACB stands for American College of Physicians. These are the instructions, and go back to the home page, and same as before we have done, copy the FASTA sequence in plain form and then paste on this particular forms, and all the settings will be as by default as we discussed earlier. And now simply on the submit, click on the submit. Click on the submit, then the result will be shown in some moments. Try it again. Most of the online servers sometimes issues, maybe updating issue, etc. So in that case, the results are not shown, and we are trying maybe results. Now, as we can see, the results are NetCTL 1.2 prediction using MHC supertype A1 threshold 0.750. In this window, we can show almost 298 peptides. In other words, these information First of all, ID sequence. This is PEP stands for peptide, and now this sequence is the peptide sequence. And the next information is efficiency value. Next is the scale efficiency. Is next value is the cleavage value, and the second last is the depth transfer energy, and the last is the prediction score, which we discussed. It must be in 0 to 1. Higher will be the top rank, and for overworking, we can select top ranked peptides on basis of their prediction. Simply, if you want to save the results, just copy here and just copy first 10 peptides and go to the notepad. Now, these are our peptide sequence, and if we uh, check the antigenicity of this particular peptide, copy this particular sequence and simply go to the vaccine and paste that peptide. Select the target organism, virus, threshold 0.5, and submit. Now, this is the peptide sequence, and the result is 0.36. Probable it will be non-antigen. This is all about my today's video, and later on we will move forward to the immunoinformatics. Other